Hello, this is Scholar Strife. We're doing some math today in geometry. We'll be looking at properties of trapezoids and kites. So first off, what is a trapezoid? It is a quadrilateral with one pair of sides parallel to each other. The other sides are not parallel. So only one set of opposite sides are parallel. That's what makes it a trapezoid. If I were to label this A, B, C, D, A, B, and D, C are bases. They are the sides that are parallel to each other. Base angles are angles of the bases. Angle A and angle B are bases, or base angles. And so are angle D and angle C are base angles. So they come as a pair. So we got the upper base and the lower base. The legs would be AD and BC. They are the legs that are not parallel. Or they're the sides that are not parallel. They're considered the legs of the trapezoid. And a isosceles trapezoid is a trapezoid whose legs are congruent. The diagonals must also be congruent. So AC should be congruent to BD. Those are the diagonals. And AD, the legs, and BC should be congruent. And then also the consecutive angles, non-base angles. So angles that are not next to each other but are also not considered the pair as a base. So we're talking about angle A and angle D are supplementary. So they add up to 180. And so does B and C. Angle B and angle C add to 180. Okay, the mid-segment of a trapezoid. Actually, that's a parallelogram. There we go. That's another way of looking at a trapezoid. The mid-segment is this line here. So let's have A, B, C, D, and E, F. In this case, EF. So this is a trapezoid, so these are parallel to each other. The EF is the mid-segment, and it joins the midpoints of the legs. So E is the midpoint between A and D. It's in the middle. So that means this length here is the same as that length. And this length is the same as that length. The mid-segment is also parallel with the bases. And the length of the mid-segment is equal to this formula here. You add the bases together and then take half. So for example, if this was 6 and this was 8, then the mid-segment would be 6 plus 8, and then we take half, which is 1/2 of 14, so 7. So this length would be 7. A kite kind of looks like this here. It has 2 pairs of consecutive sides. So there's one pair, and then here's the other pair. If I do this right. This side is congruent to that side. So 2 pairs of congruent consecutive sides, but the opposite sides cannot be congruent. The diagonals are always perpendicular. So this line and that line create right angles. 4 right angles. One pair of opposite angles are congruent. So it could be, I don't know which pair, but they're opposite of each other. So I could say those 2 angles are congruent. And then the other pair of opposite angles are bisected by a diagonal. So these are split in half. So let's go do some examples. Example 1, use slopes to show that CDEF is a trapezoid. So we're looking at the picture here, and we're going to assume that this line is parallel to that line. So how do we show that? We use the slope formula. So remember, slope formula is rise over run, which is the difference in y's. So y2 minus y1 over the difference in our x-coordinates, x2 minus x1. So we're going to look at the slope of DE. So I'm going to use their coordinates, 1, 3, and 4, 4. So y2, so let me label this x1, y1, x2, y2. So 4 minus 3, those are my y's. And then my x's, 4 minus 1, so I'll get 2 over 3. And that's my slope. Now let's take a look at my bottom base. Okay, slope of CF. So we have 2 minus 0, that's my y's, over 6 minus 0. And we'll get, oh, sorry, 4 minus 3 is 1. Okay, 2 minus 0 is 2, 6 minus 0 is 6, so this reduces to 1/3. So because these slopes are the same, then we know that the top base is parallel to the bottom base. But to prove it's a trapezoid, the other 2 legs are not allowed to be parallel. So you would find the slope of CD, which would be 3 minus 0 over 1 minus 0, which is 3 over 1. And the slope of EF would be 4 minus 2, 4 minus 6, which is not equal to 3. So therefore, they're not parallel. So if the coordinates of point E are 7, 5, what type of quadrilateral is CDEF? So they're changing point E to 7, 5. Okay. Slope of our new EF would be 5 minus 2 over 7 minus 6, which equals 3 over 1, which is 3. So opposite sides would not be parallel. So this would be a parallelogram. So once again, CD had a slope of 3, and now if they change point E, the slope of EF is the same as CD. That means both sides would be parallel, and that's what is the definition of parallelogram. Quadrilateral where both opposite sides are parallel. Example 2. A shelf is in the shape of an isosceles trapezoid. So remember isosceles trapezoid, the legs are the same, the diagonals are the same, and they want us to find the measure of angle N, angle M, and angle L. Okay? So because we know it's an isosceles trapezoid, we know that angle N is equal to angle K, which is 50 degrees. We also know that consecutive sides that are not base angles are supplementary. So angle L plus angle K, for example, is equal to 180. So 50, or angle L plus 50 is 180. So angle L is 130. And that also means angle M is also 130. So this only works for isosceles trapezoids. Okay. Because if we go back here looking at trapezoids, we know that the base angles of a trapezoid are the same. But the consecutive angles are supplementary if and only if it's isosceles trapezoid. So let's look at checkpoint 2. So we know that angle C is also 135 degrees. So angle C equals 135 degrees. And we know that 180 minus 135 is 45. So angle A is congruent to angle D, which is equal to 45. If we didn't have that theorem that said that the consecutive angles that weren't base angles are supplementary, we could still use the formula n minus 2 times 180, and that will give us the total amount, which is 360, because this is a four-sided object. That would give us 360 degrees. And then we would subtract 360 minus 135 times 2, which is 270, which would give us 90. And since there's 90 degrees left over and there's two angles that we know that are congruent, we would split that in half and get our 45. Example 3. Find the length of the mid-segment MN in trapezoid PQRS. So we know that this is the mid-segment because it divides the two legs into two congruent parts. And we have the formula, the mid-segment is equal to 1/2 base 1 plus base 2. So we add up the bases, which is 16 plus 9, which is 25. Half of 25 is 12.5. Or you can leave it as a fraction, 25 over 2. Find the length of the mid-segment MN. Again. So once again, we're going to use the formula 1/2 times 12 plus 30. Adding the bases together. So I'll get 1/2 of 42, which is 21. So the mid-segment here is 21. This is 12.5. Find the measure of angle T in the kite shown. Okay. So we know that the sum of any quadrilateral is 360 degrees. All the interior angles, they add up to 360. And we know that one pair of opposite angles are congruent. And since we know that angle Q is not congruent to angle S, that means angle R must be congruent to angle T. So once again, because angle Q is not congruent to angle S, that means angle R and angle T have to be. Because for it to be a kite, one pair of opposite angles must be congruent. So since we know that, I'm going to call angle R and angle T X. X plus 70 plus 88 is equal to 360 degrees. So I'll have 2x plus 158 equals 360. And then I'm going to have to cut this video short. Have a good day.